Keep going.
And then we started to develop our own lithium-ion batteries in a pilot facility in Waterbury, Connecticut. We made a prismatic cell and had some designs on making an 18650. But the real kicker to what we were doing was building standard packs to go into all those devices. And we had some success in camcorder, although you know what happened to camcorders, they disappeared pretty quickly.
Yep.
We actually had a 70% share of all the ODM market in Taiwan. The ODM saw a great advantage to putting a standardized battery in there and reduced down a lot of their engineering costs and doing a lot of things like that. And we worked very hard in creating standards across the interconnect with the battery, the ASIC inside, many of the fittings.
Right.
And if I go way back, the very first customer we ever ran into was IBM, who at the time was building a portable computer with a lead acid battery attached to it, which they announced, I think it was at the PMA show, the photo show. I'm not sure how you got to the photo show, but I think that's where it was. And we had a conversation with them about passivation, and that turned into a great relationship with us and IBM for a few years, or quite a few years.
Yeah. So if you're tuning in, Paul is self-describing his background, right? Going back to the Duracell, era. So that's helping me a little bit, Paul, for what we're doing today, right? Welcome to Content Evolution nuWorld, folks. Paul Stratton is our guest speaker. And Paul, how long have we been collaborating? 20 years, 25 years?
25 years, maybe even a little more.
Yeah. We have started and closed businesses. We have, successfully, he was a, very strong contributor to IBM's marketing advisory board, during the era when I was there at ThinkPad. Candace was part of that era. Mike McGuire is on with us, our co-host here of nuWorld, and I'm just kind of looking around. What we're talking about probably doesn't sound unfamiliar, to some of you on the call. But Paul has wandered, based on his business development and broad skill set, into a great opportunity to bring storage beyond what he was doing at Duracell. And by the way, all of the things that went along with Duracell becoming part of Gillette and Procter & Gamble and all of those, that's another call by itself, Paul, right there.
I was going to say.
It's all the interesting things that happened during that era. But he's at Ambry now, right? And so we're going to talk about energy storage at scale, large scale, not in your notebook, not in your mobile phone, or even in your car, right? It's, this is for, big applications and, for things that, have some challenges in terms of weather. So we're delighted to have him and talking about, moving, what you might get from new energy sources into storage so that you can use it another time, generally what in the title, that's the arbitrage, that he'll talk about. So Paul, delighted to have you with us. And I understand that you helped Mike Reed improve his golf game, right, over the weekend. Good for you. Right?
We did, yes. We had quite a bit of fun. That was excellent. First of all, thank you for having me here today. This is a great project that I'm working on. I am going to be the first one to admit that most of the work that has been done by this company is done pre-me. I've been there about 6 months and taken on the role of managing government relations and government business development. So a really great role, which I'm very excited about. What I'm going to do is walk. Hopefully, I'm sharing my screen now with any luck. Is that true?
Not yet. it may be that I need to unpin your.
How's
Oh,
that?
here it comes. Here it comes.
There you
Yep.
go.
Excellent. So today we're going to talk a little bit about energy storage, and I want to give you just a 5-minute background on Ambry, just so that you have a reference point on who we are and what we do, and then talk a little bit about the market and why that market is leading towards some unique opportunities out there for individuals and companies. So first, if I can make this work. Ambry is an energy storage company. We make long duration energy storage batteries. What we do is produce a battery that lasts about 20 years. It has a 20-year lifespan, and that's on cycling it daily. It has no safety problems whatsoever in comparison to something like lithium ion. For all intents and purposes, this is dirt. And I say that with a lot of confidence because, well, what happened there?
We can hear
You're
you.
still
We
there.
can see everything.
It just went down on my screen for some reason. We use antimony and calcium in a calcium phosphate electrolyte. And when we ship that battery, it is unenergized. So it moves to wherever we want to place it in the world in a completely uncommissioned status, and therefore is 100% safe. Even when it's in place, it is very safe, but we can talk about that at a different time. It has no safety elements or concerns whatsoever. We use very commonly available materials. As I said, antimony, calcium abundantly available, antimony available in 13 different countries around the world, and in plentiful supply for our needs. We have a comprehensive IP portfolio. We're over 100 patents now, about 50 of them issued, the rest in process, but we're well protected. And we don't see anyone else making any kind of footprints in the category. So it's a very unique kind of category. There are little bits and pieces out there, but no concerted effort to try and play in the category with us. We have currently placed 3 test modules into actually data centers. The largest and the one that we can talk about is with Microsoft. So we're quite happy about that. That's kind of where we are at this instant. We will be selling directly to utilities and essentially the grid scale energy market. We will be building and operating our own plants, and we will be selling a complete system, not just the cells. We decided early on that we had to integrate all of the electronics into our container rather than having someone else take over that role. And that was basically because we are so different that it makes a huge difference when you switch out from something like lithium ion and into an Ambry cell. So we have some unique qualifications and capabilities in that whole area to accompany ourselves. A tiny bit on the background of the company. The company was spun out of MIT in 2010. The founder was a fellow named Donald Sadoway, who was a professor at MIT in the chemistry category. He and one of his PhD students evolved the technology from about 2010 through 2017 and started actually raising significant amounts of money in about 2017. Our investors include Bill Gates' private fund, Reliance Energy, John Paulson and Company, Forrester, Go Rosen, Japan Energy Fund, to name a few. There are just an A-class group of investors, and we're very excited about that. To date, we've raised about $225 million, and we're in the market right now as we transform into a high volume manufacturing plant We're in the market through JP Morgan raising more money, and we expect to close that in sometime, probably in July or August at this instant in time. If you like good stories, I have just a quick one to tell you about the interaction with Bill Gates, which you might enjoy. Donald Sadoway was teaching a class which included an online component, and during his class, or after his class, he returned back to his office and was confronted by his administrative assistant and said that one of his online students wanted to schedule a meeting with him for about an hour to discuss his technology. And Donald turned him away and said, I don't do that with online students, kind of thing, you know. And came back the next day, and the men said, listen, you know, this fella has called back a second time and is really kind of persistent about wanting to get a meeting. And Donald looked at his admin and said, I told you, I don't do that with online students. I just don't have time. Third day he came back, and the admin said, this person who keeps calling says it's Bill Gates. And Donald looked at her and said, wow, he is persistent, isn't he? He said, but I'm still not taking the bait, right? Like this is just a very aggressive online student. The fourth day he came back, and the secretary said, I have Bill Gates on the line for you. and that was the beginning of the relationship with Bill Gates. So I always kind of get a kick out of that. It's always interesting to share. So just to give you perspective on what our product looks like, this is the base cell that we produce. It's roughly the size of a car battery. We place about 50 of these into a tray, and then we place about 10 trays, sometimes a few less or a few more, into a 10-foot shipping container. That shipping container is 8 feet wide and 9.5 feet tall. And that gives us, in this full container on our newest specifications, about 1 megawatt. So each of these containers is roughly a megawatt, and has lots of great attributes to it. We assemble those into solar and wind farms. And this is just a picture of what a 32 megawatt installation would look like. This is 32 containers, all of roughly 1 megawatt each, and all of the power electronics required to do that, and inverters and power management systems. You'll note that ours are double stacked, which is an interesting feature that demonstrates our safety component. Lithium ion and others cannot do that because of fire concerns. We are also tightly packed, and that is something that gives us a space advantage inside of places. So I'm not going to belabor that, but what's happening in the world is really creating a need for more energy storage, big energy storage. And as you can see by this chart, we've got a big shift coming away from fossil fuels and into some of the newer fuels. Nuclear is going to remain relatively flat in our forecast models. We're going to see small scale PV increase, and that's basically residential. We'll see PV in the utility side grow dramatically. We'll see offshore wind grow dramatically, onshore wind grow even more dramatically, and some of the other technologies in biomass and geothermal grow along with us. So that by the year 2050, we expect 70%, 74% of all the electricity in, my screen just went blank. Did I lose something? Or?
Nope, you're still there on our side.
No, that's interesting. I lost my.
You're good.
There we go.
Fine.
Oops. I must have a connection problem. We expect about 74% of electricity generation to come from renewables by 2050. I just listened to a presentation from Bloomberg, who were quoting that 92% of the new electrical capacity in the United States came from renewables last year, which, when you take that into consideration, it's a giant number. So on a global basis, the cumulative investment between 2020, 2050 exceeds $1 trillion. So it points to it being a very large and significant marketplace that's evolving. There are several sectors in the US to the marketplace that are very interesting for us to look at as a company, and should be very interesting to other marketers in the marketplace. The primary market for electricity in the United States is developing into really kind of like 4 distinct areas: energy shifting, energy transmission, and distribution. Residential is growing, but it is a small piece of what's happening in terms of residential solar and the like. So what we see is an optimal solution for intraday storage, enabling energy shifting up to 19 hours. So what we're saying here is that we're going to be able to collect energy from the sun and from wind projects, and then be able to store it for up to 19 hours and offer it back to the grid during times of no sun and low wind. Our battery, I may have said, or I'm not sure if I did, is a long duration. We can store energy somewhere between 4 and 24 hours. And this gives us a very strong capacity to be able to extend transmission and distribution markets for the ISOs of the world and whatnot. I wrote in there that we have a very high response level. Also, our battery comes up to full power in about 10 microseconds. I'm sorry, 6 microseconds, which is about 0.0006 of a second. So virtually instantaneous. What we're seeing on the market, and I apologize, this is a 2019 chart, so it's even been improved since then, but this tells the story that we want to be able to tell anyway. And what we're seeing is the cost of renewables, both in solar and in wind, decreasing below the cost of natural gas combined cycle. And if you're not familiar with combined cycle, that simply means that it's using the exhaust out of a burn off of an engine to provide extended power into the grid beyond simply what's coming out of the natural gas turbine. So what we're seeing is prices dropping on the basis of fairly extensive reductions from 2022 through 2050, but the net is that we see some of these new long duration energy storage systems being more competitive than what natural gas has been and is forecast to become in the future. So we're going to see a lot more adoption of energy storage. I guess that's the net of all of that. To date, 22 states, 2 territories, and 70% of the largest utilities in the United States are driving towards low carbon electricity. That's up substantially from just a few years ago, and it continues to grow kind of on a daily basis. I shouldn't say daily, but certainly monthly, when we're seeing a lot more uptake. I was just at the Clean Power Conference in New Orleans, and to put a little bit of perspective on that, we had a year ago, they had 118 exhibitors. This year they had 470 exhibitors, which, just begins to tell you that it is, vastly growing at a very fast pace. We also had, I believe the number was 8,000 attendees this year, up from about 2,000 a year ago. So one of the great shows that's growing dramatically. It's widespread across the United States. Those states that are committing to zero carbon, and commitments are, as I said, continuing to come in a big time way. As we see this market grow, in 2040, the megawatt capacity exceeds the combined cycle natural gas of 150 gigawatts of energy. So we will have a very strong position to support solar energy and wind energy, as you can see from this chart. What we're demonstrating here is a wind onshore in this category here, the solar utility in here. I believe this is, I have to just check, wind offshore, correct? So between both sets of wind onshore and offshore, plus the solar capacity that's being built by utilities, we're going to see 41% of the US's energy commitments being fulfilled by 2040. And that's about a $225 billion market, which will be fed and supplemented by the 4 to 10 hour storage market that companies like Ambry and chemical systems or battery systems like Ambry will be able to fulfill. So just and this is a little bit of a complicated chart. I actually considered not putting it in, but essentially what this demonstrates is that by the time we get to beyond sort of hourly storage, which is really the forefront of what lithium ion can do. Lithium ion is very strong up to about 4 or 6 hours. But we get into a need from some of the wind and solar that's being collected for a longer duration. And you can see this line here begins to depict the 10-hour segment. So we're into a day-week category, but 4 to 24 hours is really dominating, and this 4 to 10 hour category right here is dominating the need that is evolving in the marketplace as we speak today. There are all sorts of other systems out there, including hydrogen and lots of things that will fulfill the seasonal needs and the sort of weekly needs as time grows and goes on. It's a relatively complex kind of matrix of what's going to, be built into the various time factors that are required. But we see and have a lot of documentation to believe that the 10 to 24 hour category is very strong, and that will likely fulfill 100% of the decarbonization goals in 2040. The other thing that we're seeing is a shift, and this is just talking a little bit about what it looks like to see what the usable energy costs are going to be across both Ambry, and I use lithium ion energy storage as a benchmark here to compare against. And what we're seeing and forecasting is that some of the costs now, we're looking at an average cost of what it would take to put capacity in the market today of just roughly in the $170 a kilowatt hour per year average, reducing down to in the 150, 160 range at 2030. And that will continue to decline. When we look at lithium ion in a same scenario of interaction, we're seeing lithium ion today up in the 325 range, and then moving down into the 260 range. And this is just designed to present a trend towards chemistries like ours and systems like ours. We have 3 advantages over lithium ion in the grand scheme of things. The first is simply materials. Our materials costs are far lighter than what lithium is paying for nickel, cobalt, and lithium. We have antimony and calcium, both abundant and both far cheaper than any of those. The second component is, you put a system in, you want a system to last a minimum of 20 years. Our system lasts for 20 years, daily cycling, with a projected 5% degradation of the capacity. So what does that mean? That means that if you start off with 100 megawatts in a system and you cycle it every day for 20 years, you'll have 95 megawatts at the end of that 20-year period. And we are seeing strong evidence that we may be overstating that degradation at this instant in time. We're really not seeing any degradation. There is no moving parts. There is nothing to wear out, nothing to deplete inside the cell. It's quite amazing to look at. Lithium ion, on the other hand, has a replenishment cycle of somewhere between 3 and 5 years that you need to supplement or augment the capacity of the installation with new capacity to replace that has been depleted by cycling. So we're seeing a maintenance cost in there, we see a cost of augmentation or replacement in there, and we see higher materials. The other thing, the other contributor to cost is safety. We have no need for fire suppression equipment. We have no need for any kind of safety elements that are as extensive of what a lithium-ion battery would require. In fact, and when I showed you that stacking of the containers back a few slides ago, it gives you an indication of what we can do to also optimize space and space utilization. So just putting that in perspective, if we look at the projected pricing in the capacity market applications, or in our projected system pricing, we see a number of opportunities, and we see a real advantage coming into our projected cost line being very much aligned with the $50 capacity market. And what that means is $50 per kilowatt hour per year on the open market. Capacity is essentially the installed base that a utility would offer to maintain total connectivity in an environment over the period of a year. So that $50 mark is kind of, actually, I read something this morning and it helped me see it a little better in my mind, but it's kind of like the overhead that you're required to hold as a utility in order to meet the needs of your community. And that is a base price that is required. As soon as you start to use electricity, you would start the clock ticking on top of that and have a per kilowatt hour consumed price on top of that. But $50 is kind of what they're looking at as the end market capacity pricing out into 2030. We see our product getting there. When you look at the projected price of lithium ion, I'm sorry that the scales are different here, but they're a little bit offset. If we're looking at a $50 capacity, we're seeing quite a gap between where lithium ion can get to and where a system like Ambry's can get to in the marketplace. Fairly good size difference. Projecting a robust market for us in the future. And I have to admit, there are other chemistries and systems out there that will be equally positioned in the future with nickel, or I'm sorry, with liquid metal products like ours. So what's that mean? Generally, capacity market prices are expected to trend upward as fossil fuel plants are decommissioned and renewable generation becomes increasingly more available. So we're seeing it in all of these different districts around. The one that gives you a really good insight into what's happening there is the New England ISO. And we've seen pricing from the 2014 era of $85 to $180 per kilowatt hour, or per kilowatt a year, I should say, and decreasing down in 2019 to $46. This is really kind of a little bit different than other areas would see it, because it's highly influenced from imported electricity coming out of Canada and Quebec. But it just points to the fact that this $50 number across the United States is probably going to be a pretty good number for us to be looking at. So now what do we see out there in the arbitrage market? So we're seeing that daily variances are running in 2018, 5.7, 5.1. These are the prices that renewables can be purchased for in the marketplace, or what power can be purchased for. So power coming out of the renewable category is going to be very aligned with the numbers we see here at roughly 5 cents per kilowatt hour. And that creates a wonderful market for us to be able to fulfill a lot of the things that have been happening in the fossil fuel fueled electricity markets across the United States. This just gives you a little bit of an idea of cost per milliwatt hours and how it goes up and down across on a daily basis across the United States, and talks about the fluctuations in those prices. I don't know what else to tell you in this particular category at this instant, but you do see great variances in the cost per megawatt hour on a daily basis throughout the United States. Getting that curve to flatten with an import of renewable energy through storage and through availability of renewables as they're in operation, sun's up and the wind's blowing, makes for a big difference in how the utilities will be able to manage their capacity costs. So we're seeing, as you see right here, huge changes. We can flatten that curve out dramatically. So I know I didn't go too deep into it, and hopefully you get the idea. Hopefully you get the concepts and market opportunities and market positions that we're talking about here today. There is a large opportunity for 10-hour battery storage, and it's going to really help us stabilize the grid, especially as renewable penetration rises to the extent that we believe it will, driven by decarbonization, and also reliability of the grid, which is the second component of what the government is pushing towards. Decarbonization and reliability are really the two driving factors. Lithium-ion systems are projected to be a little more expensive than where we see the energy capacity shifting and opportunities for arbitrage in those markets. And we see a lot of projects coming on. That's basically what that's saying. So without Ambri type products, we don't think that it's really possible to get to 100% decarbonization under the guidelines set down by the Biden administration, and we're happy to be part of it. So with that, I open it up.
Outstanding, Paul. Thanks for sharing that, unpacking it for us. And Mike McGuire, again, thanks for being co-host of CE nuWorld. You had a question in chat. Share it with all of us and Paul.
Paul, I was just curious, are you seeing, out here in California, or at least the Bay Area, there's a lot of incentives right now to install the heat and cooling pumps right now. Does that kind of the evolution of those kind of systems in-house, does that put more pressure on the grid? Does it create more of an enabling force for the Ambri solution or those old kinds of alternatives?
Yeah, I don't have a specific comment back on that, Mike. Anytime you're taking power off the grid to power something, it obviously enhances the need for higher power generation, and that would speak to even more need for renewables to come on board at a faster and better pace. And certainly, anytime you see the opportunity for a renewable to come onto the market, it just makes really good sense. I mean, and this is the part that I find a little bit frustrating in the United States, because we built all of these wind farms and solar farms, and we didn't require that they have storage.
Right.
And you think about it, gee, the sun doesn't shine at night and we get a lot more energy out of the sun than we need during the day. But wouldn't it be great if we could gather that and store it and then put it back in when we really need it, right? And the same with the wind. So a lot of these storage projects, and even a little bit of a comment on building out of renewables. There's a lot of there's over I think the guy quoted this the other day at this conference that I was at, $1 trillion worth of projects in the world waiting to be initiated, and that's wind and solar combined. And what's holding it up? What's holding it up is two things: permitting. Permitting is a big, huge issue out there, and the time that it takes to get permits to do all these kinds of things, and then interconnection. Each state has their own interconnection rules and guidelines and all these kinds of things that take time to solve. They have to be solved before mega projects can go into operation, and that takes time. So, and then the last thing is the availability of resources, and resources not only in the battery side of it, but in the wind and solar side of it also. Companies are backed up with the appropriate equipment to be able to make the installations complete. So that will solve itself through time, of course, but at this instant, it's slowing everything down, and we're getting caught.
One of the things that is pretty apparent, once you look at the current way that we deliver electricity to ourselves, is that there's a lot of electron waste, right, in terms of transmission, right? So the fact is, centrally generating it and trying to get it out through a network is you're losing a lot of it, right, on the way to the final destination, right? So the fact is, by using it at its source where it's being generated, with the help of batteries, right, much more effective. And then there's the generating capacity issue of you have to build the generating capacity of an electric grid to maximum use, right, to peak capacity. And to the degree that you're shifting it over into what you're discussing, Paul, is the peak capacity load keeps on going down, right? And that's also a good thing, because that means that you can take most of those plants that do that extra capacity at peak are coal. They're coal or gas fired, all right? And so you want to not turn those on, you want to use them less and less over time, right? So those are contributors at a system level, right, to what you're trying to accomplish, in my humble opinion.
Absolutely. And you hit on transmission just briefly there, but transmission is another, there's this whole capacity shifting and distribution that is one whole market, but transmission is being brought into the energy storage, the long duration energy storage market a lot more quickly these days, and trying to reduce down the high voltage lines and get it a little closer so that you don't suffer those losses across the length of wires and distances. So there's quite a few advantages to it, and we're going to see, I think, all of those markets open up with lots of opportunity for utilities and whatnot to take advantage of solid cost of goods, so to speak, or capacity.
Yeah. Ben, join us. You had some thoughts in chat.
Yeah, a couple of things. I used to work for NIPSCO, Northern Indiana Public Service Company, on gas and electric load forecasting and so forth. And you saw an industry that changed from a focus on generation to a focus on distribution control. And I was looking, is it fair to say a high concept to look at what you are is store and forward, repurposable and scalable store and forward engines that can can transform a smart distribution network. And it's heterogeneous, so I can take energy forms and store and distribute them. So small and large scale can make a much smarter distribution network, and therefore ease the generation focus.
Yeah, I'm not exactly sure how to respond to that, but yes, you know, anytime we can make these grids more reliable, and I think that is, you know, one of the things that you were talking about there, and you know, avoiding situations like we had in Texas a few years ago. So we get the benefit of reliability, we get the benefit of decarbonization by taking out those peaker plants and things that have been fossil fuel driven the last few years. And go ahead.
Oh, no, I was just saying more predictable distribution management.
Absolutely.
Using small scale and large scale storage units allow a much more intelligent and active flow control that will ease the burden on the generation side, whether it's sun, wind, or coal.
Absolutely.
And next,
Actually, I did. Go ahead, Kevin.
no, Mike goes.
I want to clarify.
I'm going to go over to Dan. Go ahead.
Okay. Thank you, Kevin. Paul, you'd mentioned that one of the obstacles is permitting. And were you saying specifically that's permitting for the creation or installation of generation plants? Or do the units that you guys create, those kind of the storage things, require special permitting? I just wanted to make sure I was clear on that.
No,
that obstacle.
It's a total project. As soon as someone opens up an opportunity to build a wind farm, for instance, or a solar farm, we're integrated into that. So we're part of the permitting process associated with that. But we would see, you know, some of these projects can take many years to get through the permitting process. Now, the government, through the encouragement of DOE, has recent steps to try and better align and make more efficient the permitting process. And we've just seen some legislation come out in the last couple of days, actually, that should enhance or make more efficient the permitting process.
Right.
But it's still, you know, one of the bigger mitigating factors to you know, creation at this instant.
Right. Thank you.
Dan Ness, join us.
Yeah, I think, Paul, you just addressed, well, and Mike too, just addressed the question I had, which is it sounds like a lot of your installations are integrated and not standalone batteries that help the grid. I was sharing the example of one that just happens to be just a few miles from my house, where AES is trying to put in a independent lithium ion battery, but they're running into problems. And of all things, they want to place it in an area known as, well, where we had some of the biggest wildfires we've had in San Diego's history. They happen to buy some property to place it on, you know, where the grid kind of comes together. And it also happens to be one where there's some highly entitled individuals, Country Club Drive, who are NIMBYs all the way. So I was just curious, with your work governmental, are you going to run into a lot of, except for the integrated ones, if you have standalone implementations, are you going to have to deal with a lot of local jurisdictions, of fire departments, of HOAs, of you know, local governments, which I mean, is that going to be part of the future?
Sure. We you know, the only way that we would have a standalone product not attached to wind and solar is to charge our battery off the grid. And, you know, that it's not an economic benefit at this instant in time. There's some economics to that work, for instance, in the case of data centers and backup power for data centers. That's a market we're doing some test and demonstration work at the moment with some great success. But our basic market, and where we believe it will, you know, evolve to very quickly, is coupled to a wind farm and a solar farm. There are a couple of interesting little things that you said in your question, though. Fire has been a big issue for some of the lithium ion installations, and I had a meeting just about a month and a half ago with this fellow who's a career fire professional who now goes around and teaches how to handle some of these, very difficult or nuanced fires, including lithium ion fires. And, if you had a fire, for instance, on your country club drive in a lithium ion facility there for whatever reason, and who knows, there could be lots of reasons you can have one. A fire department, unless they're well trained, would simply stand there and say, "We're not touching."
Exactly.
And that's a problem, of course. With an Ambry battery, we've passed all the fire certification tests at this instant in time, and we do not have any kind of gas creation or explosion, fire hazard inside the battery. So that's a big advantage for us. One of the other things that I think I'm a little bit curious about, and if any of you have had any experience with this, would be interested in hearing. It's the noise created by the storage systems in situ. I had a fellow the other day came back and asked me how much noise our system created when installed. And I had to sort of stand there and think about it for a second and go, I don't think we have any noise. There's no air conditioning units. There's no, moving parts. For all intents and purposes, it's
Right.
quiet. And he was talking about some of the other systems out there that have auxiliary motors and auxiliary things that create a certain sound entity that can be a sense of or a source of pollution, I guess, to certain areas. But has anyone run into that at all? Any of their?
Paul, is it your understanding that a lot of that auxiliary stuff is heat dissipation, active heat dissipation?
Could be active heat dissipation. It could be a lot of these systems have a need for air conditioning.
Well,
I was going to say
that's exactly the point. Yeah. Okay. So, thermal flow, is an issue. For those of you who remember David Hill, right? He used to talk about designing a notebook computer was essentially the same as designing an air conditioner, right? From a, industrial design point of view, is how do I get the, flow of air through the thing in a way that, it doesn't, melt as the processors and components, heat up. But, and that, by the way, for supercomputers, it's exactly the same, right? They get really hot. Okay, so we're going to go to, does anybody have an answer for Paul? If you do, we're glad to entertain it. Stuart, you're next.
Yes, sir. Thank you. Yeah, so Paul, I've been doing some investigation into alternative energy sources, in particular nuclear and hydrogen, and looking at that. And because solar and wind may not be able to maybe completely satisfy the needs that we have, and especially in a world that increasingly needs more energy. So in a world, let's say, where nuclear and hydrogen begin to take off and become more and more of the energy grid, is there still a need for your long duration storage? And if so, what is it? What other kinds of uses do you have for long duration storage that might be in addition to what is going on with renewables?
Sure. No, good question. I'm not sure that I can fully answer it, but I can give you a couple of thoughts that I have on that. Nuclear is an interesting scenario because it doesn't like to be stopped and started. It doesn't like to go through this a lot. So the idea of having energy storage to supplement that and to help take out some of the variances and the ups and the downs provides a pretty good market and a pretty good need for energy storage through the long term also. So coupled with nuclear, and I can't really put a number on it, but I know a bunch of the nuclear people who I have had, sort of casual conversations with are very interested in how to couple our storage system with what they're doing. Hydrogen is, it's a wonderful objective.
But it's still out there. Is that what you're saying?
Yeah, I think, well, somebody came to me the other day and they said, wow, this is such a great product. Hydrogen, you burn it and you get water as a byproduct. But in order to produce it, you need 2x that amount of water. And this is what he's telling me. So please don't shoot me. I'm just a messenger. Somebody theoretically knows what they're talking about. Said, so when you find out the amount of water to actually drive a hydrogen plant, the amount of water required, that's going to change a lot of people's minds. Now, I have, this is from a very knowledgeable person, or I wouldn't quote it, or I wouldn't say it, but I don't personally have any knowledge about how that works. So his comment was, if you think it's 5 years away, you're being overly optimistic by about 20 years. And, that was, I'm simply playing that back from someone who I was speaking to about that. But certainly hydrogen, if you can ever make it work, is a wonderful solution to a lot of problems.
Yeah. So we're going to go to Bruce Parks in just a second. Paul, one thought here is, the end of life for a lithium ion battery is,
Yeah.
I've been in there. There's some pretty nasty chemistry inside of a lithium ion battery. And so, where it goes after, it's done, performed its service is important. What are the end of life characteristics for an Ambri battery?
Good question.
That's a great question, and one that I'm happy to say is we have virtually 95+% recoverable and recyclable materials in our battery. When you think about it, antimony is a solid in our battery. It never changes its, from being a solid mineral in the battery, and it's 100% recyclable. Calcium and calcium metal and calcium metal, the calcium phosphate are both virtually totally recoverable simply by putting them in water and extracting them out of the system. Our cells are made within a stainless steel container, stainless steel top, and we have stainless steel on the interior to create the separation in the various compartments, which is virtually 100% recoverable also. So at the end of life, each of our cells has, just by our calculations today, about $65 of residual value, each cell, residual value in the recyclable market that has a ready market out there for it. So yeah, there's going to be a few things that are, difficult to recycle. Some of the plastics in the wiring, for instance, things like that. But for the vast majority of things in our cell, we are very confident that we are 95+% totally recyclable.
Fantastic. Well, I saw your investment partnership with a group in Japan. They'll help you a lot with recycling. They care a lot about recycling. So take advantage of that. Bruce Parks, please join.
Hi, good morning. Thanks for the information. It's fascinating. But my thinking centers on whether or not the use of those batteries can be used in the consumer market for homeowners, apartment dwellers, et cetera, so that you could really offload some of the demand on the grid itself, or are the systems just simply too expensive to do that on that kind of a basis?
It's a good question, and our product as it exists today, and we have the one product, which is the container. We're going through some changes on the cells on the inside that will enhance their capacity and output, but the container itself will remain our baseline product for the foreseeable future. Let me put it that way. It is not a consumer-based product. It weighs a lot more than you think. It weighs about 65,000 pounds. But once it's in place, And as I said before, it can be stacked and all sorts of things, and that's just not practical for a residential type market. We do have numerous, let's say, governmental agencies, including the DoD, which are evaluating our product for installation into sort of bases in a variety of places around the world, where they would be a single based container that would supply energy at needed times. And we talked a little bit before about, you can charge our battery off of the grid as long as you do it relatively frequently. What
Right.
they're looking at is disruption of supply in some of the upfront encounters. So having a battery that charged off the grid that was always ready if the grid went out would be, an example of getting close to the residential market, but not really, kind of residential, so to speak.
But I was just to take off where Bruce was going. But I could see perhaps in maybe more suburban areas or even semi-rural, right, where one of those Ambry containers could theoretically be an emergency source for a small neighborhood, right? But I guess, but it would have the intelligence to operate, as a controller of a grid controller, if you will, for like 20 homes. Is that the kind of thinking, or is that still not too small an opportunity for what you guys are doing?
That's not something that's on right now, but certainly those kinds of scenarios are things that are, kind of in the far out planning stages, or thought stages. We don't have any the market that we have right now, and just to put it in perspective, we have $6.4 billion in advance order interest in the company at this instant, and about $1 billion in committed sales at this instant. So that's going to take a couple of years to kind of move through, and so our more advanced kind of thinking in smaller sizes and different kind of scenarios will be forthcoming, but it's at least 5 years out at least.
Is that a potential opportunity or application of the technology that the company might consider licensing to a third party, or to maybe pursue that sort of residential community usage solution types of things? Or do you think that's something you guys would ultimately want to pursue yourselves?
I think it's far enough away that we'll always consider what people want to do and take a look at licensing opportunities, but I just don't think that one is within kind of foreseeable future.
Understood. Gotcha.
When it gets into that, then possibilities will abound. So
Yeah, I mean, given the weight considerations, you can understand why you would be ruling out anything other than a terrestrial, use case. It doesn't make sense for, transportation systems, although I might rule in a barge, okay? Because, you would be able to do water displacement, you can do a lot of stuff, right? If you're using water as your friend. But with that said, Paul, fascinating. We're at the top of the hour. You want to give us some concluding thoughts about where you see Ambry 10 years from now? And then we'll say thank you.
Oh, wow. Well, first of all, our journey at this instant is we're currently building an innovation center in Milford, Massachusetts. We have a facility in Marlborough, Massachusetts, which we will be moving out of in the next year. The new facility will be our pilot line manufacturing facility. It will be the demonstration model for high volume manufacturing. That blueprint will be taken into our high volume manufacturing plant, which we believe will be starting construction in 2024, fully operational by 2026, with partial offtake in 2025, of course. From there, we believe that that model will be adaptable to anywhere on the planet. And, I mean that basically saying that 65,000 pounds can be moved anywhere, of course, but it's nicer to be closer to some of the markets, especially in the overseas component, but also within the contiguous United States also. So we would see high volume manufacturing plants in key locations in the US, and then with key joint venture partners in various locations around the world. We have a lot of hope that Ambry is really kind of, as Donald Sadoway, the founder, said, it's batteries from dirt. And that just speaks to a lot of things. It speaks to cost, speaks to safety, availability. It's just got a myriad of positive things to think about. If you ever have the opportunity to talk to Donald, he's an incredibly invigorating person and just full of great ideas. So his vision is that we can power a lot of the world with Ambry batteries and liquid metal chemistries. So hopefully we'll see a large percentage. And by a large percentage, I mean 3 to 5% of the world powered by Ambry batteries at some time in the future.
Yeah, anybody doing a business case saying total addressable market, well, we'd be satisfied with 5%.
Yeah,
That's a pretty good business case. Well, I want to remind everyone that this is an open community. If you have folks that you want to invite to future editions of Content Evolution nuWorld, let them know. Mike and I will be on a call in 2 weeks talking about this community and its future. So, we welcome your thinking and, thoughts as we have that, discussion with an open mic, right, for your thoughts. And Paul, we did have one more question that while I was talking, came in from Candace Sutterston. So if you would just entertain her question and we'll conclude. See, Candace? We can't hear you.
Hold on.
Okay.
Okay, can you hear me now?
Yeah, we can.
Sorry. No, I was just building on Mike's question, so I'm not sure the attention is needed, but this idea about potentially having smaller rural HOAs and whatnot, there are HOAs that have their own water and sewer system. So
Right.
I was just wondering if, in the future, this might be another alternative to having backup generator, which are powered by fossil fuels for those kinds of instances.
The community effect, I think, would be the size of the community is really going to dictate the economics behind whether or not an Ambry battery and supporting generation, power generation, whether it be wind or solar or other means, will dominate that or will dictate that. And it may take time to figure that out in a more precise way. But, heck, 10 years from now, who knows? And, we would be delighted to develop a product that met those needs within the confines of what we need to work with in terms of charging and regeneration of the power. So
I just can't imagine there aren't, I hear it out in California, I think every Caltrans facility along the major highways, Caltrans being the, main responsible for road maintenance and safety, et cetera. I think the last 20 years, all of those major centers along the highways have solar panel, arrays in their parking lots, et cetera. And I would think, especially in those areas that are, as Candace said, in some of those high fire risk areas, this becomes a pretty obvious, I think, for a lot of those smaller communities, right, that are in and around those areas, particularly around recreation areas. I would think this would be a no-brainer for them. Even with the physical plant or footprint issues, this would seem like a piece of cake. I mean, a very easy decision, again, depending on the availability of your solution. But because I can think of several right now that would probably fit the minimum requirements you would have.
Yeah.
right? Just in that they all have some sort of wind or solar capture, and just don't have the storage, because that's, you know, what so many of it wasn't running air conditioners in some of those houses in those areas people were worried about. It was refrigeration, you know, et cetera. That was, they just needed a couple hours a day kind of thing is what you end up hearing. Just being able to trickle that out, you know, for a stranded community, I would think would be the most responsible path we could see a lot of our local politicians and whatnot regulators follow. Because, you know, again, I know it's a lot more complex than I'm describing, but this would seem to be right in line with some of the needs they have.
Yeah. And again, the other thing I'll leave you with is what's enabled all this is a capacity cost of 5 cents per kilowatt hour. And, you know, moving these systems to be able to produce that is really what's opened the market up and made it viable for all of these kinds of considerations. It's taken chemistries and systems a long time to get to that level of pricing, but that's really what's driving it. Phenomenal amount of work that's gone in to achieve that.
Well, Paul, we really appreciate you spending the time with us, sharing, you know, what you're doing at Ambry. It sounds fantastic. Probably the first location that could, you know, take an Ambry battery, probably the villages in Florida, you know, but you know, eventually it'll scale to something that is, you know, a little bit less monumental. And again, all the best. We wish you well. If you have any questions for Paul, I'm glad to direct you to him as you after you listen to this.
And
All the best, my friend.
Thank you all for being a great audience and listeners. So I appreciate time and input. Thank you.
We'll talk soon.
Pleasure.
Everything you do, be intentional, folks. Cheers.
You bet. Bye-bye.